All right, guys, welcome back. And today we're going to be going into 1.2, which is going to be about domain and range. And so for a think slash warm up, I just have which of these have you seen or not seen before? I'm going to assume that we've all kind of heard about domain and range, maybe. Um, and we've probably definitely seen this. That's called interval notation, and this is just telling us that um, we are looking at every number all the way from negative infinity all the way up to 4, but not including 4. And then we are going at every number all the way to infinity again. And this is called set builder notation. And this is saying the same thing. So this says x, and then these two, the colon there, x such that x is in the reals, but x cannot equal 4. And it's saying the exact same thing. That's saying x, this x is in the reals is saying x can be any number except 4. That's our exception. And it's saying the exact same thing here, right? Negative infinity to infinity, but we're not including 4. They're saying the exact same thing, and we'll get into a couple more examples of that. But so domain is the set of all possible input values, or in our case, it's going to be all of the x's on a graph. And then the range is the set of all possible output values, which output values are the y's on a graph, right? But not looking at a graph here, we have a set of this looks like the inputs and this looks like the outputs because the outputs are the ending stage. And so the domain, keep in mind, the domain and range are sets. And when we talk about sets in math, again, for those who don't know the concept of a set, I just like to think of it as a box, right? Right now we have a box with nothing in it, and a box is just something that you put stuff in. So now this box has a marker in it, right? Just like in math, a set is just a box that I like to think of. A box that you just put numbers in. It doesn't mean anything crazy. It's just somewhere that you put stuff. Um, and when we do sets, we do these little squiggly brackets here. So the domain is all of the inputs, which in this case is this set A. So all the inputs are 7, -1, and 0. Right? Those are the three numbers we have in our inputs. And then our outputs, notice, our outputs are only, this 1 isn't being used at all. So our outputs are only 8 and 9. All right. And then similarly for this one, right, when we have ordered pairs, x and y, this is usually input, output, right? So domain is all the inputs. So it would be all these x values, 1, 2, 9, -7. 1, 2, 9, -7, that's our set. And then the range is going to be all the y's, which is going to be 3, -5, 28, and that last one is 5, positive 5. Right? So inputs, outputs. That's all you need to know. Domain is inputs, range is outputs, or on a graph, domain is all the x's and the range is all the y's because those are the inputs and the outputs on a graph. So for domain and range, we can either use interval notation, which I talked about at the beginning, or set builder notation. And then there's one more alternate way to write them, which I will go over. So interval notation uses parentheses when not including a number and brackets when including a number. So if I didn't want to include, let's say we had, let's just think simple and let's think on a number line, right? Let's say I have, let's say 0's there, -2's there, and 2 is here. And I'm open dot here and I'm going, and then I have a closed dot of 2. So that means -2 is not included. So I would use a parenthesis, and then we're going all the way till 2, but that +2 is included, so we would use a bracket, right? And then whenever we have infinity, so if we have negative infinity to infinity, whenever there's an infinity, we use that parenthesis. And then in set builder notation, this just starts with x, and then those two dots are x such that, and then this just says x is an element of the reals, or x is in the reals, and that's just saying that x can be any real number, right? And then you put the restrictions here in this empty space. And I think it'll make more sense once we get into an example. So here, the three things we would be, so let's look at the domain for a second. Let's just look at the domain. So keep in mind, domain is all of the x's, right? So let's just look at this x-axis. How far are we going to the left? And it looks like we're going to negative infinity, right? All the way to the left is going to be negative infinity. So in interval notation, we're going to have that open bracket, and we're going to negative infinity. But then notice that we kind of come to this point right here at 6, and on both of these, it looks like we're getting really, really close, but we're not touching at negative 6. So in interval notation, we're going to have to close off at negative 6 and use that parenthesis to tell us we are not touching negative 6, right? But then notice right after that, we have x values all the way out to infinity. So we're going to have to use this thing called a union, which is just a big U, and that's essentially just saying and, right? And we start right after negative 6 again, and we go all the way out to infinity. And so what this essentially is saying is we are hitting every x value possible except negative 6, right? We're going from negative infinity to negative 6, but then it never touches. But then right after that, we also have right after negative 6 all the way to infinity on the x's. So that's one way to write it. And then the set builder notation, I think, is good for ones like this. So we have x such that x is in the reals. So x can be any real number. And then we're going to name our restriction, which is that x can't be 6. Right? And that's all the interval notation is saying. It's saying x can be anything except 6, right? Because at 6, this is where we are not touching, right? And then the simpler alternative way to write it is you could just say x can't be 6, right? And so let's look at a couple more of these graphs. Determine the domain and range of each graph. So for these ones, I'm going to like to use interval notation, just because I think those ones are going to work the nicest. So the domain, keep in mind, is all the x's. So let's look at the x's, right? This x-axis. And what's the farthest left we go? It looks like we're here at negative 11 is the farthest left we go. And then notice we have an open dot, so we better have a parenthesis to note that we're not including negative 11. And then the farthest to the right we go looks like positive 11, right? But that 11, it has a closed dot, so we're going to include it. And to include it, we need those closed brackets. So that is our domain. And then our range, we're looking for the y's. So we're looking up and down. What is the lowest point? The lowest point looks like right here. And that is at 1. And 1 is included, right? And then our highest point looks like it might be here at 8, right? And there's one here too at 8, and that's okay. And that is also included, right? We don't have like one of these open dots or anything over at 8. So that's all this graph is. Let's do it one more time. So for the domain, we are looking at all of the x's again. So what's the farthest to the left we go? Well, it looks like right here, the farthest left we go is -5, and that is a closed dot, so it's included. So we're gonna have brackets, -5, and then what's the farthest right we go? The farthest right we go is here, which is at 3, +3, and again, that one is a closed dot, so that is included. So we will put that bracket there for 3. And now, one last time for the range. Now we're looking at high and low. We're looking at the y. So what's the lowest point? The lowest point looks like it's here and here. They look like they're the same at -9, and that one's included. So brackets -9. And then what's the highest point? Looks like it's here and here, and that is at -4, and that's included. And that one's a little tricky, right? Because we have negatives, but -4 is bigger than -9, right? It's higher up. So that is correct. Now, determine the domain and range of these graphs. So this one gets a little complicated, right? If we were to do interval notation, we kind of have that thing earlier where, look, again at -6, where we never really touch -6, do we? We just get really close on the x's. So let's look at the domain first. And the same thing happens here at 4, right? The same thing kind of happens there at 4, where it never really touches. So in interval notation, this one is going to get a little crazy. In interval notation, notice how we're going to end up going all the way out to -infinity on the x's. So we can do -infinity. Then we get stopped at -6 again. And we're going to have to pick up with a union at -6 again, because we're good on the x's in here, right? So, and then we go all the way up to 4. Well, 4 is not included, so we have to leave that out and pick it up again over here. And then notice from 4 onward, we are good all the way to infinity. So that would be interval notation, which gets a little messy when we have 2 breaks like that. So let's do set builder notation now. We have x such that x is in the reals, so any real number, and then we just name our restrictions. And this is where it's a little easier. We say x can't be -6, and x can't be 4, +4. And then we'd write our little squiggly line at the end. And that one I think makes a little more sense. And then also we could just write x can't be -6 or 4, which I think that is even easier, right? But on Delta Math, it might not let you. It might force you to do this interval notation, but it will fill out this first part of the interval notation for you. And then for the range, so that's the domain. That's just 3 different ways to write the domain. And the range, notice, up and down, we are going all the way down to -infinity and all the way up to negative or positive infinity there. So our range is -infinity to infinity, or you can just write all real numbers. And on Delta Math, there is an option for you to click just all real numbers right away, and it'll put that in there for you. So just one more quick example. Let's do the domain first again. The domain looks like we hit +7, and it looks like we'll end up going all the way to the left. So it looks like we're going to use everything to the left here. So in interval notation, if we're going all the way out to the left, that'll reach -infinity. And then we stop at 7. And it looks like that 7 is included, so we'll use a bracket. And for set builder notation, it would be x such that x is in the reals, the same start every time. And then we would name the restriction. And the restriction is x has to be less than or equal to 7. Does that make sense? So x can be 7 or anything less than 7. And that's all that's saying. And now we could also just write x is less than or equal to 7, right? That's the domain. Anything 7 or less, we have x's. Now, for the range, same idea, except now we're looking at up and down. So the lowest the y value can be is here, which is at 0, right? So the lowest the y value can be is 0, and it looks like we touch, so we'll have a closed bracket. And then, although it kind of looks like we're going off to the left, I think eventually, if we keep going, we're going to go up and up and up and up forever. So that would be infinity, and whenever we have infinity, we end up with a parenthesis. And again, just for the builder notation, the way to write that in set builder notation is x such, or this time it'll be this time it'll be y, right? Y such that y is in the reals, and then our restriction is going to be y has to be greater than or equal to 0. Same thing, such we would replace x with y, or you could just write y is greater than or equal to 0. That's the simplest one. So that is going to be it for domain and range. And really, we just have to remember it's like what x values can we use and what y values can we use.